talk about what is a container, why we'll use Apptainer, when to use containers, what are the downsides, performance issues, trust and security issues. Then we will give the demo with TB Lite, and then if there is more time, we will also discuss how you can run GPU-enabled containers, and then some common issues when using Docker images with Apptainer and solutions. So what is a container? A container is a software package. So it's a package, a container that contains everything that you need to run your software. So all the elements are there. And so it's like a small operating system in a package, right? So, and it uses OS virtualization. So the operating system is mostly inside your container, except for the kernel. The kernel will be the kernel of the host will be used inside the container, but everything else will be inside the container. Okay. So what are the advantages? Well, most big advantage is that it's portable. That means that you can make your container somewhere and then move it to another system, and it should, in most cases, just work. So because everything is there, you don't depend on the host operating system. It's also more secure because it's complete. You can make it completely isolated from the host environment. So you can run, if you really want, unsafe stuff there, and you can be safe that it will not go into your host environment. And the third big advantage is that it's reproducible, because everything is installed in your container, and you can make it so that it will not change. So it will always run in exactly the same way. It's again not dependent on the host. So if something changes on the host, the thing will still work in exactly the same way in your container, right? And then we have to make a small distinction between a container and a container image. So the container is a thing that runs your application, and the image is all the files that are needed to run this thing. Right? Okay, so we are using Apptainer in the VSC clusters. Apptainer is very similar software to Singularity, which was the previous name of Apptainer. So they changed the name from Singularity to Apptainer. And then there was a fork of it that changed the name to Singularity C. You don't have to worry about all that, but just to mention, like, okay, both softwares will be very compatible. If you made your container with Apptainer, then you will probably also be able to run it with Singularity and vice versa. So why are we using Apptainer? Well, the focus for Apptainer is on integration into HPC clusters. So there's always a trade-off that you have to make between isolation from the host and integration with the host. So Apptainer focuses on the integration part. So it sets some default bind mounts, makes the network available by default, and also makes the GPUs available easily, right? Another advantage is that it doesn't require root privileges. So normal users can just run Apptainer containers on the VSC clusters without having root. You can also build containers without root. We will see that in the afternoon in the building containers session, and we will use there the fake root option for that. Other advantage of Apptainer is the mobility. So an Apptainer image is just a single file, just a single zip file that you can easily move from one system to another, right? And a nice thing that Apptainer also has is that it provides verifiable reproducibility and security via immutable images. So these ZIF images, they are immutable. You cannot change them. Once you have created them, they're fixed, they're static. So you can be sure that there's not tampered with, and they can also be signed. So you can be sure that what you get is exactly what you want to get. And Apptainer also has support for the Docker format. Docker uses the OCI format, that's the Open Container Initiative standard. So it's able to just pull from Docker Hub, for example, and you can just run it like that. But of course, it doesn't use the OCI format, so it has to convert it to its own format before it can be used. So when should you use containers? Well, one reason that you can use it is to try out software. If you have access to a container for the software that you want to try, then it's very easy to try it because everything is in there and it will most probably just work for you. So that will be a quick way to test it before you will do the proper installation with a performance optimized build and so on. Second reason can be for portability. So you have something built, for example, on your laptop, and you want to just run it also on the cluster. That's possible if you package it up in a container, and then you can just move it there. Reproducibility, of course, if you see someone who has published a paper about some algorithm, and they've packaged it up in a container, then you can easily reproduce it. Just take that container and run it yourself. And then you're sure then it will run in exactly the same way as the developers have intended it. Also nice is that it's one file, so it will save a lot of inodes. This is especially important on distributed file systems where the number of inodes is quite limited. And then the last reason why to use containers, this is more for the HPC support staff. When users ask something to install for us, but it has a huge dependency tree, it's very complex, very strict versions. Then as a last resort, we will usually just provide a container for you and then say like, okay, here you can have your software. Okay. There are, of course, some downsides also to containers. Check. Okay. So one downside is that it will not easily integrate with software outside of the container. For example, the software models that are installed on the clusters, in most cases, they won't work well together with the containers. Also, for the applications that are installed on Open On Demand, in many cases, they won't work. So this is quite big downsides. Another downside is MPI. So if your software needs to run with MPI, it can be done. It's perfectly possible, but it's a bit tricky. You have to be careful because the software has to be built with an MPI library that is also compatible with the MPI on the host. And the portability aspect, it is very portable, but it's not 100% portable. It still depends on the CPU architecture of the host where it was built on. So you cannot transfer it from a system where it was built on an x86 and then transform it to an ARM system. This will usually not work. Another downside is that container images can be quite large. But yeah, for today's standards, this is a rather small downside. If it's a few gigabytes, it's usually not a big problem. And there are solutions to make it even smaller. Just remove all the files that were needed to build your software. Just keep only the files that you need to run it, right? Okay, and then performance aspect, this can also be a downside. So most container images that you find in public registries are built for generic CPU architectures. So they're not built for performance. Why is that done? Because, of course, that increases the chance that it will work everywhere. But, of course, there's a balance. If you optimize for portability, then the performance will, of course, suffer. But in any case, it's still possible to build containers with high performance, but then you will lose again the portability aspect. We will see more about that later. Trust and security, this is a big one. So you have to make sure that the container that you are running, that you know what's inside, that you can trust it, no? That you know how it was built, configured, patched, and so on, and which versions are used. And it's also very important to, when you download, for example, from Docker Hub, that you download from a verified publisher. So not from some random guy that you don't know what he put inside your container. So it's really a full package. So anything can be in there, all right? It's important. 10 minutes, okay. So if you have a container and you're not sure if this is safe, then you can still run it in a safe way by using the contain option. So then you will be sure that everything will be contained inside the container. But of course, then you don't have the integration with the host. So if you then still want to have access to some files on the host, then you can add some bind option here. So this here, oops, this is not working.
Yeah, just
so
delete.
here, the bind option.
No, it just deletes. It works.
Oh, yeah. Can I click on it? Yeah. Okay. Anyway, I will not. So here is a list of public container registries that you can use to just download Docker containers mostly. So you have Docker Hub, which is the biggest one, but there's also the NVIDIA container registry for containers optimized to run on GPUs. Similar for AMD GPUs, AMD Infinity Hub, and also on GitHub, you can also publish your own containers if you want and make them publicly available. Okay, now we're slowly going to using Apptainer containers. So one thing to take into account is the startup behavior of those containers. They can be controlled through the environment and through a run script. So the environment is a bunch of scripts that is located at this location, .singularity.t/env. So here you have a bunch of scripts that are executed to set up your environment. So they set up some environment variables for you. And those will be executed whenever you do Apptainer run, Apptainer exec, or Apptainer shell. Then there's also a run script, and the run script is located here in this location, and that will only be executed when you do Apptainer run. So things that you would put there is, for example, activate a Conda environment to make software available and some things like that. Okay. So the first thing that you have to do is set up some environment variables to make sure that your home is not filled up. So I already did that for you, but if you want to run containers with me, then I suggest to use those commands in your shell. Okay. So here I have an example where I pull an Ubuntu image from Docker Hub. So I cannot select this. That's right.
You know, in presentation mode you can't.
Yeah. So let's do this. Is this big enough? Better? Oh yeah, this is of course not working. It's a wrong slide. Apptainer pull. So we'll fetch the OCI image. It's very small because this is a minimal Ubuntu image, so it only contains the bare minimum to make it work. So anything else that you want to have, you will have to install it yourself inside the container. Then it will extract it and then convert it to a CIF file, right? So now I have my Ubuntu image here, right? I can inspect this image. Now you can see all the labels that are in the container. And here it gives me a lot of information, gives me the version of Ubuntu. It gives me the Apptainer version that was used to create it and so on. And it was also built on an AMD 64 machine. You can also check the run script. So this is quite big file with all some setting some environment variables, which we're not going to discuss. The only important thing here is the last line, which just executes everything that will come after after doing Apptainer run. So it will just do actually not much. It will be mostly the same as just doing Apptainer exec. Then we also have some environment variables set. So we have this environment file script, which sets the path. This is just the default path for Apptainer, so it's not really necessary. And then we have another one. It doesn't contain anything except from some comments. So there's not much to see here. And then we can also run an interactive shell inside our container. So we can have you see that I now have now a new prompt, which indicates that I'm now inside my container, right? I can check inside version of Ubuntu used, for example. I can also check what is my current working directory. And as you can see, I am in /tmp. This is the current directory when I was on the host, when I started it. So the current working directory is automatically bind mounted into the container for you. So you don't have to do anything. This is automatic, very useful. We can also find all the directories, all the parts that are bind mounted automatically for us. So I'm now on a VUB cluster. So as you can see, I have a lot of bind mounts, and this will probably be different if you are on a different cluster. So you can see here that what we have here, the devices are bind mounted. We have the VSC mounts, so Antwerp, Brussels, Ghent, Leuven. Then we have the user home is bind mounted. The apps, so all the models are there. The data, Scratch, and then we also have the databases here. And then you can also run some commands inside the container, but I have to hurry up a little bit because I'm running behind schedule. So you can have environment variables. If you define them outside the container, they will automatically also become available inside the container. So as you can see, I run this Apptainer run command, and then I run bash in my container, and then with this command echo myvar. So the myvar is available inside my container because it has the my value, right? And you can also set a different value in your container from your host if you want. I show this here. Okay, so let's start with the Apptainer demo quickly. So I already created an Apptainer container for TB Lite for you using an Apptainer definition file and we will show in the afternoon how to create this one. But I already created it for you, so we can save some time here. So we can again inspect this. It has more or less the same as for our Ubuntu because it was based on the Ubuntu and we didn't add any extra labels. You can also check, for example, the run script. I'm not going to check everything, but you can do that if you want. So here I have activated my Conda environment before I will run something. I've also added some help text there. So if I run Apptainer run help, then I will see the help. This is an optional thing that you can add, and then you can see how to run it. There's also some test section added there to test if the container works well, and indeed it works well. And now we can do the real test to run. So we do Apptainer run the image and then the full command. So we'll just run tblight-version inside the container, and it will give our version. We can also show that we have Python installed there. So the Python bindings for tblight, and it will show you the full path here to the tblight Python bindings, and you can see that it's inside the container because it's in opt/opt/conda, which is not available on the host. And then we can also do Apptainer exec, but this will of course fail. Why will that fail? Because the exec command doesn't execute the run script, but we can still use exec, but then we have to explicitly run the run script itself. So we can do it like this. And we can also have an interactive Python session inside our container if you want. So we can also do like this. And we have our Python, and then we can do import tblight, for example. Okay. Yeah, this was it for the demo. Yeah, I'm going to skip this one because we're over time, but you can definitely run also Apptainer containers on GPU. It works well, and it's usually works well, works also very fast. So performance is usually quite good as well. So I definitely recommend it to do. And then, yeah, here are some issues that you may have when starting from Docker images and converting them to Apptainer and the proposed solutions that you can use for them. So I will stop here to stay in time.
Any questions on using container images? Maybe a show of hands. How many people have been using Apptainer for some software?
That's quite a lot already.
How many people have been considering it but didn't get to the point yet? A couple. Okay. There's also no questions in the Teams chat, so I guess we can move on, Maxime.
Somebody raised their hand.
Ah, really? Not anymore. Ah, oh yes. Somebody was raising their hands. I'm not sure. Yeah, if you want to raise a question in Teams, you can if you raise your hand. Yeah, but they're no longer raising their hands, so I guess there's no question. If you have questions in Teams, put them in the chat. And if you want to raise the question yourself vocally, also raise your hand. Then we can let you do this. It looks like there's no question, so... Oh, yeah. Turn on the mic, yeah.
Hello. So it's just keeping in mind the TV light example. If you want to do the calculation of the example, how would you do it with the container?
Got to do that. So
You have to reshare your screen.
is
Is it still you? Yeah, okay.
I will quickly share it again. So we first have to, so it's actually the same as here. So we do Apptainer run, then the image, and then the full command. So in this case, we just run Python, and then she as a side training. There's it. Like this.
And that works because your working directory is automatically bind mounted into the container.
Yeah. So it's very easy.
I have a question. Beside Docker Hub, where would you recommend to save your container images once they are built?
To save your own container images?
Yes, where would you say? Because I can say for myself, some are taking a lot of of storage.
Yes.
And so sometimes I cannot always leave them on the scratch. So I was wondering, where would you recommend to save them?
Well, you can keep them on the VSC data if you have enough space, or you can push them to GitHub, or on GitLab. You can also push them there if you want, or on some other cloud instance that you want. Yeah, so free to store it wherever you want.
Okay, thank you.